Welcome back to History of Simple Things. Today's topic comes from one of our viewers, Hamzat Galagev. Thanks for the great suggestion. You asked, how is silver made, and where does it actually come from? Whether it's in your grandmother's old tea set, a shiny coin in your pocket, or the circuitry of your phone, silver is everywhere. But this gleaming metal doesn't start out looking anything like the polished pieces we see in daily life. It begins its story deep underground, hidden inside ordinary-looking rock. So how does raw, gritty ore transform into one of the most iconic and valuable metals in human history? Stick around as we dig into the incredible journey of silver right here on History of Simple Things. Silver is a naturally occurring element, represented by the symbol Ag on the periodic table, and it's found in the Earth's crust. But it rarely shows up in its pure form. Most of the time, silver is extracted from other ores, minerals like galena, which is primarily lead sulfide but often holds silver deep within. Other times, it can be found alongside copper, gold, or zinc. In fact, much of the silver we use isn't even mined specifically for silver. It's produced as a byproduct during the extraction of these other metals. To get to it, miners use open pit or underground mining techniques, depending on where the deposits are located. If the silver ore is closer to the surface, giant earth-moving machines strip away the overburden, the soil and rock covering the deposit, and haul out tons of ore. In deeper deposits, miners may use tunnels or shafts to reach the silver-rich rock. But either way, once the ore is out of the ground, it doesn't exactly sparkle. At this point, it's just a heavy grayish mix of rock that requires some serious chemistry to become usable silver. Once extracted, the silver-bearing ore undergoes a kind of mechanical makeover. First, it gets crushed, literally. Giant jaw crushers or cone crushers reduce massive rocks into smaller chunks. Then it's ground into an even finer powder using ball mills, where rotating steel balls pulverize the material to the consistency of flour. This isn't just for convenience, it's all about increasing the surface area. The finer the particles, the more effectively silver can be separated from the surrounding waste rock. After grinding, what remains is called slurry, a mixture of finely ground ore and water. It's from this slurry that silver begins to separate from everything else. But here's where things start to get a little more technical and magical. Next up is the flotation process, especially common when silver is found with other metals like lead or copper. The slurry is mixed with chemicals and air is blown through it. What happens is quite clever. Those chemicals cause the silver and other valuable minerals to become hydrophobic, meaning they repel water and cling to bubbles. As the bubbles rise, they carry the silver-rich minerals to the surface, forming a frothy layer. This layer is then skimmed off and dried. What's left behind is a silver concentrate, a far richer version of the original ore. Now, it's still not pure silver. This concentrate often contains a mix of silver, other metals, and impurities. So, it's time for the real purification to begin. Smelting is where fire meets rock. The silver concentrate is placed in a furnace and subjected to extremely high temperatures, often above 1,000 degrees Celsius. At this heat, the metal melts and separates based on density. Silver, being heavier than many impurities, sinks to the bottom. Slag, the lighter waste material, floats to the top and is removed. If lead was present in the original ore, it may be used to collect silver during smelting. This method, known as cupellation, dates back to ancient times. The lead absorbs the silver, and once it's all melted together, The mixture is placed in a special porous dish called a cupel. When reheated, the lead oxidizes and gets absorbed into the cupel, leaving behind metallic silver. At this stage, the silver is still not pure enough for fine applications, but it's a recognizable metal now, shiny and soft, just waiting to be refined even further. To achieve the high levels of purity required for electronics, jewelry, or investment-grade bullion, silver goes through electrolytic refining. Think of it as using electricity to polish the silver at a molecular level. In this method, impure silver is used as the anode, while a thin sheet of pure silver acts as the cathode. Both are immersed in a bath of silver nitrate solution, and an electrical current is passed through. Over time, silver from the anode dissolves into the solution and redeposits onto the cathode as pure silver. Impurities like gold and platinum drop to the bottom as a sludge known as anode slime, which is collected and processed separately, often for valuable byproducts. After refining, the final product is 99.9% pure silver, sometimes called 3/9 fine. This is the same grade used in fine silverware, investment coins, and high-end electronics. Once refined, silver is usually cast into large bars or ingots for storage or sale. These ingots can later be remelted and fabricated into virtually anything, from thin wires for electronics to sheets for solar panels to intricate shapes for jewelry. Silver might seem old-fashioned, especially in a world dominated by digital everything, but it's anything but obsolete. In fact, silver is more relevant than ever. Beyond its use in jewelry and tableware, it's found in smartphones, solar panels, electrical contacts, medical devices, and even water purification systems. Its antimicrobial properties make it useful in wound dressings and hospital equipment. And of course, it still carries economic value. Silver bullion and coins remain popular among investors. So the next time you see a silver ring or spend a silver coin, you'll know there's more to that shimmer than meets the eye. There's an entire story behind it, a story of digging, crushing, refining, and molding, a story of science, tradition, and craftsmanship. Silver doesn't just appear, it's made through human effort and ingenuity, shaped over centuries by techniques that continue to evolve even today. It's a quiet reminder that even the most common objects often have incredible journeys behind them. And silver? It's one of the best examples we have of beauty born from beneath our feet. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. If you enjoyed this video, please check out our other bingeable channels. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.